Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the 3.4, which is the real zeros of a polynomial function. So let's look at to this example 1. Given a polynomial px, x cubed plus 5x squared minus 18x minus 72, when we factorize this polynomial, it will become like this. And from this polynomial, we can detect there are 3 factors including 3 zeros. Therefore, one of the zeros, when we equate this polynomial equivalent to 0, so we will have 3 zeros, which is negative 3, 4 and negative 6. So for each factor here, the power or the multiplicity is equivalent to 1. Therefore, for the zeros of for each zeros, negative 3, 4 and negative 6, the multiplicity is equivalent to 1. Let's look at to the example 2. We have this polynomial function. When we factorize the polynomial function, we will get like this: x minus 1 power of 2, x plus 2 power of 2. So actually there are 4 zeros or 4 factor, but since the factor is repeated, we just put as power of 2. Therefore, when we equate this polynomial equivalent to 0, we will get 2 zeros, which is 1 and negative 2. And for each zeros, the power is 2. For each factor, the power is 2. Therefore, for the zeros of 1, the multiplicity is equals to 2. And the zeros of negative 2, the multiplicity is also equivalent to 2. So that is the relationship between the zeros and the multiplicity. Let's look at to this example. Find a polynomial px of degree 4 which has zeros negative 2 and 4, where negative 2 is a zero of multiplicity 2 and 4 is also a zero of multiplicity 2, which satisfied P1 is equivalent to 162. When the polynomial has a degree of 4, meaning that the maximum number of zeros for that polynomial is equivalent to 4. So for this case, when we try to construct the polynomial with the degree of 4, so we will get equivalent to, in general, it should be a x minus r power of 1, x minus r1, multiply x minus r2, multiply x minus r3, until x minus r4, because the degree is 4. So this is in general, we have 4 zeros. Therefore, when we need to construct the polynomial with the degree of 4, so you must have a in your polynomial, which is a refer to the leading coefficient a, and then our zeros is negative 2, which is we have to put x plus 2 because in general it should be minus. So minus minus you will get positive. So x plus 2 and negative 2, the multiplicity is 2. So we will put 2 here and another zeros, which is 4, x minus 4. The multiplicity also equivalent to 2. So when we try to expand x power of x power of x, so altogether we will get x with the degree of 4. And now we have another information given here. P1 is equivalent to 162. Therefore, P1 is equivalent to 162 by using remainder theorem. So what we can do here is we cannot assume A is equivalent to 1 because we do have additional information where given P1 is equal to 162. Therefore, we need to get the values of A from the information given. 162 is equivalent to A, unknown. So substitute x with the values of 1. So 1 plus 2 squared and 1 minus 4 squared. So from here, when you calculate, you will get A is equivalent to 2. And once we get the values of A is equivalent to 2, then we can proceed with substitute in the polynomial function. So which is 2x plus 2 squared and x minus 4 squared. So you cannot leave it in terms of factor form, you have to leave it in terms of general form. So you need to expand everything. At the end, you will get Px is equivalent to 2x power of 4 minus 8x power of 3 minus 24x squared plus 64x and then plus 128. So this is your final answer, which is polynomial function with the degree of 4 in general form. Now let's move on to the discard rule of sign. It is to find the possible maximum numbers of positive and negative real zeros. So let's look at to the previous example. So on this example, we know that the zeros is negative 2 and the multiplicity is 2, and another zeros is 4, the multiplicity is also equivalent to 2. So from here, we can detect there are two negative real zeros and there are two positive real zeros. Since the multiplicity is 2, meaning that our zeros is actually 4, 4, negative 2, negative 2. So it is considered two negative real zeros and there are two positive real zeros. And by using this card rule of sign, actually we can detect how many positive and negative real zeros by detect the changes in sign. So let's look at to this example. So we have here the first term here, the leading term is positive 2x power 4. So from positive to the negative sign, they are first variation. And then the next one, this is positive to negative sign. And then next one, from negative to the negative 24x squared, there is no changes in sign. And the next one, negative 24x squared to positive 64x, we consider as a second variation in sign. So that is how we detect how many possible positive real zeros. So they are 2 or 0 positive real zeros. So by using this card rule of sign theorem, the possible positive and negative real zeros depending on the changes in sign, and it will reduce by 2 from the variation in sign. For example, the variation in sign is 2, therefore 2 minus 2 you will get 0. So the possible positive real zero is either 2 or 0 positive real zeros. And then how can we detect the possible negative real zeros? So for possible negative real zeros, we have to substitute x with the negative x. So 2 negative x power of 4 minus 8 negative x power of 3 minus 24 negative x squared plus 64 negative x plus 128. So when you expand the negative sign, you will get positive 2x power 4 and then positive 8x cubed and then negative 24x squared, negative 64x and positive 128. So we have to detect how many changes in sign here. So from positive to positive, there is no changes in sign. And the next one, from positive to negative, this is the first variation in sign. The next one, there is no variation in sign. And the last one, from negative 64x to positive 128, there is another variation in sign. So this is the second variation in sign. So there are two variations in sign, meaning that there are 2 or 0 negative real zeros in this polynomial function. So let's say you have 5 variation. So let's say you have 5 variation. So they are the possible positive or negative real zeros. They are 5 or 3 or 1 positive or negative real zeros. Let's say you have 6 variation in sign. So they are 6 or 4 or 2 or 0 possible positive or negative real zeros. So if you have 1 here, for the odd number, for the odd variation in sign, the minimum will be 1. For the even variation in sign, for example 6, 8, 4, the minimum will be 0. Because 1, when you minus 2, you will get negative number. So it is impossible for us to have negative or positive real zeros. So that's why the minimum should be 1 when it is odd variation in sign. When it is even variation in sign, the minimum will be 0. So for this case just now, we know that our positive real zeros is 4 and 4, which is 2, and the negative real zeros is negative 2 and negative 2. They are two negative real zeros, and from the discard rule of sign, we can detect there are two negative real zeros or 0, or two positive real zeros. So this discard rule of sign tally with our solution, which is two positive real zeros and two negative real zeros. So let's look at to this one. We want to detect how many possible positive and negative real zeros. So I will show the first example here. So for the positive real zeros, for the first example, there is no variation in sign here, and we have the first variation in sign from positive to negative. This is the first one, and from negative to positive, this is the second one. So there are two variation, meaning that there will be two or zero positive real zeros. And then for the negative real zeros, we have to substitute x with the negative x. So p negative x is equivalent to 2 negative x cubed plus negative x squared minus 13 negative x plus 6. So when we expand, we will get negative 2x cubed plus 2x squared plus 13x plus 6. So when we look at to this variation in sign, so from negative to positive, so we have only one variation in sign here. Therefore, one variation meaning that there are one negative real zeros. So can you try out B?